How many of you guys are currently taking, you were talking to me earlier about the child development class. How many of you guys, anybody else taking a child development class right now? Okay. And you're also doing the observations of the little people? Is that what you do? Or? Yes? Okay. Because my office, I was telling you, my office used to be right there. So I had fun screaming with the kids when they were running around. I'd come off my office and scream and they would go, ah! So, if you weren't here last time, you've always got the videos up on YouTube to watch if you want to. Make sure you can see everything. Quiz next Thursday. Now, last time we covered some stuff related to how students learn how to add things. We went over, the basic idea of just putting objects together, and then you can count. If they have 2 objects, 3 objects, I have 5 objects. We talked about properties of addition. We actually started with 1, 2, so we did solve a simpler problem, make a list. So let me do this. Last time we did 1, 2, we said look for a pattern. We kind of focused in class on sequences, but if you do the homework, there's some visual stuff too. So I want you to try those out. Come back to me, Go away, come back, please. Thank you. We did make a list. And we did solve a simpler problem. Okay. So that was section 1, 2. So 1, 1 had 3 strategies. 1, 2 has 3 more strategies for solving problems. Okay. So you just got to get in there and try the homework out and let me know if you have anything weird. I mean, those problems can get a little weird because it wants to challenge you, it wants to show you things, plus you maybe you've never seen before, just to see if you can apply these things to it. Okay. Maybe. Do you guys remember what I said to keep in mind in order, like in the way I'm going to grade these? Because what can be frustrating about some of these problems? They're weird and you don't know how to get the answer, right? The more important thing is showing me how you're trying to solve it. What are the thoughts you put into it? You have got to capture what you're trying to do, even if it doesn't work. Because maybe you're just one little thing off, or maybe you had a very novel idea, but it just wouldn't quite work. And that's happened before. And I want to point out to you, that's a really good idea. Just this problem, it doesn't quite fit, but that idea you had works in other situations. Okay. Then we got into section 3.1. And we did addition. We talked about the set method for addition. We talked about measurement model. Okay. Basically, the set method is literally just drawing a set. And we'll see some more examples of what that could mean today. Trying to remember if I forgot anything else. I mean, we went over a lot of little specifics. The properties, there's a ton of properties. And you guys remember associative, commutative, all that kind of stuff. Okay. Yeah, okay, good. So what I want to do right now is if I was trying to get a student, all right, this is going to take a second. Well, I'm not going to write out every number. I'm going to do this. So this is not a multiplication table, this is an addition table. And this is the first place students start to put together things they naturally do. So when you add, very often you'll count on. That is a really quick thing that just makes immediate sense. What's 2 plus 3? Well, there's 2. 1, 2, 3, 5, right? So you can, counting on is a really kind of a natural way to do this. There's a few other things that students use to help them fill in a table like this on the way to memorizing this. Yes? What's the easiest So the way this works is, for example, right here, 3 plus 3 is 6, yes? Now, it would go to 10, but for the sake of everybody, I'm not going to do all 10, okay? What's obviously the easiest column and row to fill in? 0. What's up with 0? I think we talked about it last time. What's the big deal with 0? Besides, it always finds a way to screw us over. Like 1 divided by 0, what the shit? Does anyone remember what we call 0? We give it an official name. If I add 0 to something, it maintains its... What could you have stolen if you're not careful with your credit card information or whatever? Identity. So 0 is the additive identity. Now real quick, you guys have gone through math classes. You know, number one, math people don't say things really well. We don't name things really well, but identity kicks ass. 0 is the additive identity because it's what I add to maintain a number's identity. It doesn't change. So the first thing a student will pick up on is if I have no toys and you give me no toys, I still have no toys. If I have no toys and you give me 1 toy, I have 1 toy. So this first blah 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 in this first row in this first column, blah blah blah, easy. So 1 plus 0 is 1. Is everybody cool with how to read this thing? Because I mean it's been, you know, a little bit for everybody in terms of how the last time you saw a multiplication table. Okay. Also notice there's a property that almost makes half of this. I don't have to worry about it at first because I get it automatically. So like, what's you could do it, Jeff. What is 2 plus 1? Astonished. So then, therefore, what's 1 plus 2? 3. So like everything from here down, I don't have to worry about because the minute I get 3 plus 2, I got 2 plus 3 because I'm going to learn commutativity. Yes? The commutative property. Is that okay? Remind me what the commutative property was.
The position doesn't change the answer.
Do you?
The position of the numbers doesn't change
Yeah.
the answer.
If I'm adding numbers, if I just commute 2 numbers, if I just switch plus 2 numbers, the answer doesn't change. So that's why if 2 plus 1 is 3, 1 plus 2 is 3. Does that make, so if I'm filling this out, I really just have to worry about kind of like this triangular wedge here. Because the minute I know these, I automatically know these. So for example, if I know 4 plus 1 is 5, then I know 1 plus 4 is 5, yes? So I only have to worry about the stuff down here. You guys see that? Okay. This column here, why is this column nice? Because what does this involve? If I start at 1 and I add 1, what would a student do when they're first learning this stuff? Add 1, they're gonna, like I said earlier, count on, right? 1, 2, oh, it's 2. Yes? So this column is just all about counting on. Start at 1, count on by 1, 3 goes to 4, 5 goes to 6, amazing. What about, now here, this is something kind of nifty. This diagonal here, where'd 2 come from right here? Where'd 2 come from? 1 plus 1. So that's a double, right? That's like double 1. 6 came from double 3, yes? So what goes here? Double 2, double 3, double 4, double 5. Right, you guys? Is that cool? Okay. So, you're never going to necessarily do this explicitly. But this is a nice mapping of the strategy students can use to see what the result is of an addition as they start to memorize it. You're not going to necessarily do all of this in one day with your students. This is kind of a map of as they learn more things, they can fill in more sections. Is that? And the book basically has this laid out in itself, in it. However you finish that sentence correctly. Twos are basically counting on by two. So 3, 4, 5, and so forth. Yeah. One thing I can't really do here with what if I have 6 and 4? What's special about 6 and 4? Makes sense. So if I had the full thing, you could look for 7 and 3, 8 and 2, combinations to 10. Do you guys remember what we called that? Combinations to 10. The name of it started with CON. Certain kind of numbers that go well together. Compatible, right? Or symbolic. So they're compatible in a way. Okay. You guys, how you feeling all right? I never know how to gauge. This class has got to be a little trippy because we're talking about remarkably basic stuff. But you have to at the same time. I respect, obviously, anyone who wants to become a teacher. Because if you do it right, it's one of the hardest jobs, but it's one of the jobs you'll love the most. If you do it wrong, you can actually have a cushy life, as long as you don't get fired. You show videos all the time, but then you're screwing your students. You see what I mean? So teachers get a bad name because some people don't do their job well. If you do your job right, you're going to be working your ass off, but you're going to have all these little bright lights of light. It's just so gratifying. Okay. So, all right. I think it's enough of this. Let me make sure I didn't forget anything important. No. Yeah, good. Okay, we got it. So you could do this all the way down, and you could use the idea of doubling. You could use the idea of combos to 10. As they learn new things, they can start to fill this in, and they'll start to memorize it. Okay. Let me ask you this. This is going to be part of what we do today. Do you remember these pieces here? We used them a little bit. We're going to use them much more today. I'm going to show you base 3. You're going to work with base 4 later. Do you guys remember what we call this little dude here? Yeah, he's an absolute unit. What's this guy? Compared to this guy, he's really long. So that's a long. So this is a unit. Come back here. Unit. This is a long. Get out of here. This is a, do you remember what this is?
Flat.
Very flat, yes. And of course this would be cube. That's crazy. So what does this represent, of course? This is the ones place. This is the, careful. We're base 3 here, right? Base 3, this is 3's place. 9's place. 27. So you don't have to count these, you just keep multiplying by 3, right? But this is really kind of nice. You just keep stepping up in dimension. I don't know if you guys are with me. This is like a point. Come back. This is a point. This is a line. This is a plane. This is a cube, right? And of course, past that, we get a little funky. So we kind of stop here physically. Because how many dimensions do we see? 3. So we kind of stop with the physical stuff here. All right. No hypercubes for little kids. It's freaky. Okay, so what I want to do first is I just want to represent, like, how would you represent 163 plus 28 if you had to draw these shapes? But let's do base 10, right? So, like, what would this be if I had to draw it? 3 whats? Units. So this would be 3 units. How did I draw? Yeah, let's just do dots. That's right. 3 units. 6 longs, and instead of making little rectangles, I'm just going to make lines. Is that cool? And then 1, too far, flat. So 10 of these in a row is a long. 10 rows, 10 longs in an array is a flat, and then of course 10 arrays stack up to make a cube. And that's really good for little people because you always want to connect tactile stuff to ideas. Okay. You guys, all right. Do 28 real quick. So next to this, represent 28. Oh. Yeah, I don't need that. So 28 would be 8 units. Two lots, yes, okay. Now when I do that, it kind of feels like a combination of like Mayan and whatever, yes, but, okay. So if I'm gonna add these together, I could literally just draw all that stuff, yes? But let's see, so I got, if I add these together, which represents adding 163 to 28, I'll have one of these, 1, 2, 3, 4, 5, 6 plus 2, and then 1, 2, 3 plus 8. Is that okay? So I can just kind of scoop them all into a pile, which is what you guys are going to be doing later with the actual pieces. Now, obviously there's an issue here, yeah? What's the issue? How many are in the ones place? Yeah. So what the students are going to look for, and if they have the tactile pieces, they can literally physically put them together. And you saw the little girl, they like to, if you have the big blocks, you can click them together. They know what goes into making one of these. If I'm in base 10, what goes into making one of these? 10 of these. So if they find 10 of these, and of course this is 8, and if I do these 2, that becomes
9.
Yes. Sorry. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So then now what number is this? 199. Now listen. What idea did they not have to consider, but just happened naturally that people have trouble with when they're really young and they first learn it? What does anyone see the idea? If you actually did 163 plus 28, what would you do? How would you add it? Go ahead. Add 163, 28 by hand. Do it. Do it. Add 163 to 28 by hand. And I know you already know the answer. I don't care. What do you do? Carry the 1. So carrying the 1 is huge. Carrying the 1, I think I brought this up before. I'm going to show, well, shit. Did I bring it with me? No, I'll get it while you guys are working. There's this dumb little, I see this all the time. Parents screenshot kids' homework, and they put it up, and they're like, well, this is not the way I learned it. As a teacher, you have to be ready for parents to not understand why you aren't just telling your kid, just carry the damn 1. Why aren't you just telling my kid that's how I do it? Right? I'm sorry. I'm not practicing redneck, so I'm allowed to put a little southern twang right in. So anyway, you have to be ready for that kind of thing. Because to be on their side for a second, it doesn't make sense to somebody who's gone through this shit already. Like, why are you telling these kids? Because that's how we get there. Carrying the 1 isn't normal, isn't natural. We don't think about it that much because we've done it so much. But to get to the point where you even understand what the hell that means, that takes some time. So do you guys see how it's buried in there? And you don't say anything about it yet. You let them get really used to, oh, I see naturally this become, okay. And you have them just work with the parts. You work with the tactile stuff. You work with it. And then you start to do simple things, convert it to just numbers. And then you can bring in, hey, look what happened every time. Didn't we have to have 1 more of these? And that's the idea of carrying the 1, right? Okay. So one thing I want to really safeguard is I want none of you to have a problem with how we have to scaffold this for a student. Parents might have a problem with it because they're just knowing what they know at the moment. Okay. If you really want to get down to how I feel, I think if you ever have a kid, there should be courses you have to take, but, oh. Okay. So, we're gonna play around with this idea with like a smaller base. Number one, so that it'll fit on your desk, and number two, so that it's something you're unfamiliar with, so you'll feel a little more like your students will when they're working with base time. Okay. Can somebody remind me, just to do a little, how would I use a thinking strategy on something like 37 plus 43? I'm a young person who's gotten to the point where I can work with numbers, but I'm still not used to them that much. How could I do that?
30 plus 40 plus 10.
Yeah, kick-ass, because you're looking for compatible numbers. And when you're first starting, you're looking for small compatible numbers. Not 37 to 43, they're actually compatible. But how many of us think the answer should be 70 if we don't think about it too hard, right? Yeah, it's easy to make a mistake. So if you break it up into 30 plus 7 represents 37, 40 plus 3 represents 43, and just to be that guy for a minute, because that's part of my job, what property specifically could I use to make it become what you said? Associativity and commutativity. They almost always work together. So 30 plus 40 plus 7 plus 3. So I did associativity and I did commutativity. So I can switch those two around, move the parentheses. And now you get 70 plus 10, 8. And if you don't already do something like this in your head, that's what you should be doing in your head when you're adding 37 and 43, right? Okay. I got a lot of cool little shit that I want to show you that either you forgot, but I also think a lot of people never saw it. For example, did I tell you how to tell if a number is divisible by 3? No? If you add all the digits in a number and it's a multiple of 3, you can divide it, the whole thing by 3. Did I tell you that? Okay, so there's going to be a lot of little stuff like that that's kind of neat. Okay, well, we'll see if you agree with me. Might just be me that thinks it's neat, that's okay. So real quick, what about this? Now let's say you're a little more advanced. On one level, that really sucks. Whenever it kind of goes into the next speedometer, clicking over, kind of sucks, but what can you take from this guy to help this guy become nicer? Because what am I adding to 191? I'm adding 20 and I'm adding 9. Is that cool? And of course, what goes well with this guy? The 9. Because what's 191 plus 9? 200 plus 20. 220. Yeah. Again, these are all little things you should be using. Yourself, yeah? Okay. So let me ask you something related to what we just did. Here, let's start off simple. What's 3 base 8 plus 2 base 8? Don't overthink. 5 base 8, right? If I have 3 units plus 2 units and base 8, the answer is going to be 5 base 8. You only have to be concerned, like for example, what if I do this? What's 3 base 8 plus 5 base 8? Now I've got to be careful, don't I? The same way we have to be careful if I say what's 1 plus 8 and the kid says 9, and I say what's 1 plus 9, holy shit, now I've got to go to the next place. So what's 3 base 8 plus 5 base 8? we got some, all right. So what's 9 plus 1? So it goes to the next space, yes? Now, of course, we wouldn't think to carry the 1, but that's really what we're doing. So the result carries me over the base. So if my result is my base or bigger, I've got to go into the next place. I want this to make nothing but sense. What's the biggest single digit in base 8? 7. So if I do 3 base 8 plus 4 base 8, that's 7 base 8. There's no problem. But if I add one more thing to that, I get a full crate of eggs, just to bring that back.
Yeah, Jeff.
So then I have to go to the next place. I got one full crate of eggs, no spare eggs. Yes? So 3 base 8 plus 5 base 8 is 10 base 8. I understand some of us still don't like that. But it's if 2 things add to 10, the result is 10, correct? But what we call 10 happens to represent the next number after 9. If we had a base 8, what they call 10 would be the next number after 7. Does that make sense? Our base is 10, so when do we fill a 10? When we get up to 9, one more. Base 8, when do we fill an 8? When we get up to 7, one more. So, watch this. How do I do 7 base 8 plus 6 base 8 plus 2 base 8? There's a few different ways to do this one. So everybody, take a second. Look at me. Look at me. How would you do 7 plus 6 plus 4? Just in our base. 7 plus 6 plus 4. What would you have first? What would be the smart way to do that? 6 and 4 is 10. And then 10 and 7 is 17 now. Okay, so look back at this. Are there any 2 I give you that fill the base, that make a full base? Yeah, which 2? 6 and 2. So that would be, that's compatible numbers in base 8. That would be 7 base 8 plus, no, 10 base 8. And what's 7 base 8 plus 10 base 8? 17 base 8. Kick ass. As long as we're below the base, we could just put shit together, right? 1 plus 2 is 3 in every base, where 1 and 2 make sense, yes? Maybe. You guys get the idea? It's exactly like looking for 3 plus 7. Why are those special together? Because they make our base. So in base 8, what am I looking for? 4 and 4, 6 and 2, 5 and 3, right? Okay. So, let's see. What if I had, what do you got, Jeff? I don't know, Jeff. 4 base 5 plus 3 base 5. How could I rewrite that? What does 4 need to click over to 10 in base 5? It needs 1. And then how much more? So I can break 3 up into 1 plus, that's insane. And then this, you can do it, this is what in base 5? 10. Now, I want you to really realize this. The way you're feeling right now, is anybody completely comfortable with that? Is anybody like, I could do that, just give me a bunch of those and I could do them like that? No. Same way if you were just starting out in French class and you're like, oh yeah, I could just give me whatever English and I could turn it into French. No, you can't. This is what your students are going to feel like when they're using base 10. They don't come out of the womb knowing this shit. They don't slap them on the ass and go, base 10, 100, 1,000. No. So I need you to understand this is really good for you. Because you're going to be, part of your brain is going to be like, and you can't stop it. Part of your brain is like, come on, this is just numbers. So is this. We don't live in base 5, and the little dudes, they don't live in base 10 either yet. Okay, I think I made that point. So this isn't hard. This is not hard. It's just new. Yes? But but you're looking for the same shit, they're gonna have to learn to look for it. You guys already naturally look for 2 plus 8. Here, you gotta look for 1 plus 4, 2 plus 3 to make a full 5, yes? Okay, maybe, I'll stop. Move on, Jeff, okay. Blah. Oh, okay, all right. Subtraction, so I'm gonna talk about subtraction, then I'll have you guys work on some stuff together, and then we'll watch some little people work on stuff. That's my plan for the immediate future. Can somebody, here, let me just ask you guys, can you come up with a physical situation where 5 minus 3 is the math you'd have to do to figure it out? Somebody I don't normally hear from, is anybody, you could do, just a physical situation where you would have to do 5 minus 3 to get the result. Could be anything. Want me to start? What if I have $5 in my pocket and somebody stole 3 from me? Would I have to do that math to figure out how much money I have left? Yes. All right, somebody else, give me an example. No. Give me. Yes.
5 eggs, and I gave 4
Okay, 5 eggs, you gave away 3 eggs. Thank you. I'm looking at your face, you're like, let me save this guy. I really hope, guys, it's okay. Does somebody, all right, you all understand, there's a billion just like what you and I just did. You have 5 eggs and you lost 3, somebody took 3, you ate 3 cookies and you had 5, so you got 2 left, right? What's another different physical situation that you would have to do this for? Can you imagine? So that the result you're doing is takeaway. I had this much, you took it away for some reason. I ate it, that's taking it away. I lost it, that's taking it away. You took it away, that's taking it away. Yes? So another physical situation where subtraction will come into play. When you're comparing 2 things. Let's say you got 3 apples, right? And you sit next to somebody who's got 5. What question would lead to this word? You have 3 apples, sit next to somebody who's got 5. How many more, right? Isn't that completely different than takeaway? Okay, I really want you guys to be with me on this. I'm okay with you guys being a little on the quiet side. I'll be all right. Feel free, you can't get it wrong. I'm not going to berate you if you say something wrong. And you almost, I need you, this is what a lot of people don't understand. 5 minus 3 is 5 minus 3. You all agree? 5 minus 3 is 5 minus 3. What physical situations could it represent? A lot. And when you're a little human, you immediately connect to physical situations. You with me? So if I say, oh, subtraction means you have 5 toys and somebody took 3 of them. And then I try to say, no, 5 minus 3 is you have 5 toys, somebody else has. Those are 2 completely different physical situations. Are you with me? They are not going to understand right off the bat that relates to them. I don't know if you guys are. So we teach subtraction in a few different ways, and then eventually we hope we can get to the point where 5 minus 3 is independent of where they came from. 5 minus 3 is 2. But I can get the answer to a lot of different physical ways. Okay, so watch this. So if I do takeaway, that's the main first thing. That's the first thing people think of. To be really honest, I don't think it's the first thing that we encounter when we're humans. I think we encounter the next method, which is how many more does this guy have? But takeaway, I could do, so what if I've got $5? So I could do set method, right? Let me put that up here, set method. How would I represent, how would I draw? You don't have to draw a person. What would I do to represent losing $3? Yeah, you could cross through them. What we normally do is kind of like take 3 of them, So then what would be left? 2. So we take these 3, take them away. Okay. And of course, you don't necessarily want to lay money on the ground, but if you put 5 toys and you physically just move 3 of them over, you can see there's 2 left, right? Okay. So that's the subtraction that I think most people think of. Oh, it's take away. You take 3 away from 5. What are you talking about? But here's a totally different situation. Let me see if you guys can guess how to set up. Oh, before I get too far, what about the measurement? What did measurement mean versus set method? The measurement method? Set method are the circles with little objects inside. What did measurement method mean? Oh, okay, that's neat. No?
Not fractions.
No. But I like that idea. We're gonna do that with fractions, yeah. More basic, very basic. Number line, right? Okay. So, in the early going here, when we see measurement method, that's gonna relate to a number line. So how would I represent 5 minus 3 using a number line? Takeaway method. How do you guys, go ahead and try to draw something that you think would represent 5 minus 3 on a number line. Takeaway method. Does anyone want to share their method? Yes?
You write another line, obviously. You start at 5 and then you go back.
Ah! Number line. Kids love this because they get to show off, they know the numbers. Yes? You're like, can you just pick a number line, put your numbers? Yeah. Okay. Start at 5. So I have 5, I'm currently here, and I'm happy. Yay! And then, of course, what happens? Yeah, take away 3. You can either do this. I prefer 1, 2, 3 visually because it relates more to counting back, right? So instead of counting on, you count back. Okay, so that's the measurement method takeaway approach. Okay. So did everybody basically have that? You could do start at 5 and have an arrow back. But to me, for a little kid, I'd rather see those bounces. 1, 2, 3. Yeah. Okay, maybe. Okay. And again, I know on one level this is not ground shaking, but we're getting down to the point of making it make sense that people have never seen this before. That's trippy shit. So let me, of course, as the math geek in this room, let me give this a formal definition. We let A and B be sets. And the number of things in A is little a. The number of things in B is little b. Then A minus B equals the number of things in A minus B. Yeah, make sure, I feel like I left something else. Oh yeah, that's right, I left the huge thing out. If B is a subset of A, that's huge. There we go. What did capital A minus capital B mean with sets? It's not the same thing as normal subtraction, right? What did capital A, like set A minus set B, what does that mean? Yeah, if there's there's anything in A that's also in B, you take it out, right? Okay. Let me see. Alright. Did anybody watch Superman? The latest Superman? You did? What'd you think? What's up? Okay. I can live with that. Yeah, it's good stuff and bad stuff, right? I mean, you see any recent movies in the movie theater? What'd you see?
Fantastic Four.
Fantastic Four, I haven't seen that yet. I'm surprised I haven't seen it yet. Is that okay? Don't give me any spoilers, but
It's awesome.
it sucked.
It's awesome.
Oh, it's awesome. Okay, interesting, interesting. So I got your spectrum from Superman to Fantastic Four. Well, I mean, if you want to compare it to the last Fantastic Four movie, that was not a very high bar. So I'm happy to hear it's okay. Okay. Good. Anybody else seen a movie recently? Yes? Oh, there's a new I'm sorry. I just sort of like phase those out. They're all the same. They're sort of like Transformers now. It's like another Transformers. Was it good?
Yeah.
Okay. All right. I'll believe it. And anybody else? Anybody else? Is there any- What did you see? Conjuring. Oh yeah, that's right. They got the new Conjuring movie. Kick ass. I love me some horror movies. Does anybody hate horror movies? You, that would never go? Yes. Anybody love horror movies? Oh, okay, okay, you're my people. I love horror movies. Okay, sorry. Was it good?
Yeah.
Okay. But see, I mean, all right. Anybody else want to share? Anybody else see anything or want to see something? Yes.
There's a new Jordan Peele movie called Him that comes out this weekend.
That's right. Okay, I've heard mixed things from like critics, but you never pay attention to that in the early going.
He has a good track
But
record.
Jordan Peele being attached to it makes me excited. Yeah, because the freaking Get Out and Us.
Nope.
Get Out was insane.
Yes.
Okay. Anybody else? Does anybody never watch movies? You're like, I don't like this. What are you talking about? Okay. So, just to ruin the moment, pedagogically. Number one, I am curious about things like that. But number two, a lot of you guys were like shutting down. It's okay, it's okay. And now I'm gonna ruin everything, I'm sorry. But I just needed to get a few of you guys to open up about something, so I'd step outside of that, talk about some movies for a minute. I like the Superman movie, but I can see a lot of problems with it at the same time. You know, it's like,
Too much going on.
I know, I'm with
Are you talking about the one on Netflix? Or?
you. The more recent one that was in the theaters, I don't think it's in Netflix, is
It's
it?
on Max.
Oh, it's already out?
I would just say Max.
Yeah.
Because there was Superman 2 on Netflix. I watched it yesterday.
Superman 2?
Superman something. Like,
Superman
I was
something,
watching
I got
it, yeah,
you.
I wasn't even watching it because I wanted to watch it.
They should call it Superman Again? Question mark? Okay. Alright.
Or not Superman, Spider-Man.
Oh, sorry.
I'm so sorry.
You're right.
I just realized.
Tobey Maguire is always my Spider-Man. Tom Holland's okay. So I don't blame you if you don't go watch movies because you're starting to become the same thing over and over. But I'm glad to hear the Conjuring's good. Yeah, okay. I like the actors in it. But guys, so in general, all right, you have to help me out a little bit. I kind of live off of feedback. I live off of discussions. I'm not saying you have to, but don't self-censor. Just give me whatever you think, right? You can't be wrong. Okay. All right, coming back to this, and I got to remember about him. I just read something this morning about it. Does this make sense? Let me give you a really specific example. So if I have A is A, B, C, D. Recall that B must be a subset of A. So can somebody give me one thing that B might be? What could B be so that B is a subset of A?
BCD.
Yeah, B, C, D. I love it. How many things are in A? 4. How many things are in B? 3. What is set A minus set B? So everything in A, from that, take away everything in B. So anything in A that is in B, you must take it away from A. What's left? A. Little a dude, right? You guys see that? Everything in here, that's also in here, must go. So all I have left is this. How many things are in A minus B? Set A minus B. 1. And what's n number of things in A minus the number of things in B? 4 minus 3, 1. So that is the concrete example related to the formal definition. Now, real quick, why do you guys have to know this? You're not going to show a 4-year-old this, right? This is to help you realize they're thinking about sets of objects. That is what they're connecting with. So this is the math looking at it as if it's sets of objects. You with me? So this is the theory behind what's actually going on in the mind of a young person when they start to grapple with subtraction. This is an example of you have to know more than what you're teaching. Maybe. Screw each other. Can't believe you like Superman. I was okay with it. I should say it that way. One of the best Lex Luthors in a while. Blah, 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 blah. Now, okay. Oh, good. Okay, good. Everybody's favorite moment. I can shut up. So let me give you these. So here's what's going to happen. I've done this once before, I believe, right? With you guys? Little objects to put you in. So whatever you're hoping to get, we'll see if you get it. All right. So I think I have a list of what they are. What do I have? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Ooh, a few more people came. All right, give me a second to calculate. Oh, that'll make, okay. Okay. That would make 3, 1, 4. That might be the best, yeah. So real quick. First person that says something. Who should I throw out? Which group should I throw out? Which group shouldn't exist? The fish, the rockets, the turtles, the pineapples? Fish? First thing I heard was fish. So, that's too bad. Nemo has been eliminated. Nobody will find him. I'll let you guys work out your little fish civil war. All right. What's up? Did you not get what you wanted? Strawberry. Robot. Everybody get one? Oh, sorry. Sunflower. Everybody got one? Okay, so everybody help me out. We threw out the fish, right? Yes. Fish, come on. All my strawberries are my strawberries. Strawberries? Strawberries. Strawberry, come here. Bring your stuff, probably because other people might inhabit your space. Strawberries right up here. Sorry, this is wet for some reason. So make right. Robots. Any more robots? Robot over here. Robots right there. There should be 3 of you, I believe. Robots. It's right there. Sunflowers. I think that's what it is. Flowers. See them? Flowers. Yeah, come up here with Chillin'. I lost the letter. All my sunflowers, you know where you're headed. You're gonna sit next to Chillin' right here. She of the multi-sticker. What about turtles? Turtle. Megan's a turtle. Who else? Hermit turtles. Oh, you can go right back here. It's got the whole area. They're gonna come to you. Any more turtles? Turtle. Way back there. Pineapples. Got a pineapple, pineapple, pineapple. Why don't my pineapples go over there? Right there. And then rockets. For the last one. Rockets. Where are my rockets? Any other rockets? Rocket, rocket. Maybe you guys can go in the back there if you want. Right there even. There's a whole area right there. Yeah. That one's split. Sorry. Somebody put their drink down. Now, let me give these out.